This is module number 20. I can't believe we've done so many videos. And this is another one of those where there's lots of pages involved in this one, but really there's only 3 examples, and then there's some questions to follow for the textbook, okay? So hopefully you did the last module and figured out how to create an ICE table, which is used to figure out concentrations of these different gases, if you will, at equilibrium, okay? So for this one here, we are covering pages 25 to 34. There's a whole bunch of questions in the bottom of 34. But again, there's only a couple of questions as an example, and it's just practicing the ICE table. Okay, so for the first part here on page number 27, it gets you going with an example question. And again, here's your question to set up with, and of course you're given information, things like what is the equilibrium constant, and it tells you if you've got 0.6 moles of PCl5 put in a 12-liter container, what would be the equilibrium concentrations of those gases. So clearly you're given an initial concentration. You can figure out what the change in concentrations are going to be, because in this case you're only given one gas to start with, so it's this gas right here. So everything on this side of the equilibrium expression is going to go up, and then this one's going to go down so that you reach equilibrium. Once you know the K value, then again you can set up your expression with the concentration of your products over the concentration of the reactants and figure out what those concentrations could be. Okay. Set up the ICE table. Once you've got your ICE table, and again, does this make sense right here? Let me highlight it for you. The answer is right here. I have an initial concentration, and I know that because it was given to me in the question. I know that this concentration is going to go down because it's the only gas that I have to start with, okay? So clearly it's going to go down. It's going to go down by a factor of 1, so let's take it minus X. Let's look at the gases on the product side. You can see here that I start with 0 of both of these gases. Clearly they're going to go up. What ratio are they going to go up? Well, if this guy goes down by a factor of 1, this is going to go up by a factor of 1 and up by a factor of 1, because the coefficients in front of my balanced formula are 1 to 1 to 1. Down 1, up 1, up 1. Does that make sense? Okay. So let's pop it up, pop in the equation X and X. Now, if you solve, you end up with a KEQ value of 0.041. That was given to you in the question. Oop, there we go. Now, solve for X, and here's what you end up with. Yikes. You end up with this value, or this expression here. What are you going to do? Well, here's where you may have to take these values, pop them into the quadratic formula, and solve for X. Are there any in the following examples that you have to use the quadratic formula for? No. So this is our only example we're going to try with this, okay? Now, at the end, you know that you get positive or negative values. Clearly, it's going to be a plus value, 0.029, because X can't be a negative value for here because we're talking about gases, okay? So therefore, at equilibrium, what do? Well, you just plug in the number. That was the X value at equilibrium. And the value for the PCl5, simply do the math and see that the concentration at equilibrium clearly has gone down for this value. Okay, here again are the steps for how to solve that. So you're going to work your way through examples, 3 examples only. So give them a go. Practice on your own. This is more of a module that we would be doing at school, and it'd be like a work period. I'd explain a little bit at first and then say, way you go. See if you can do it, and the answers are all given below. So I'm going to scoot all the way down to equation number, oh, maybe there is a quadratic you have to do. I don't think there was. I didn't think there was, though. All the way, I'm going to scoot all the way to example number 3, and I just want to make sure that we can we understand this idea of the change in concentration when you have an equation like this, where it's not balanced to start with. So if you need to balance that, how are you going to balance that? Let's put a 2 in front of here and a 1 in front of here and a 3 in front of here. Once you've got your balanced chemical equation for your equilibrium, you can solve. There's my coefficients going into my equilibrium expression. And then I want you to see if this makes sense, because you're changing the X values. Okay. So for this question, you were given the initial concentrations. There we go. ICE, ice table. My initial concentrations as given to me in the question were 0.32 moles per liter and 0.66 moles per liter and 0. How do you figure out what your X value is? How do you figure out what you're going to be doing for this question? Well, you are going to be looking at what it tells us in the question. If you look at the question, you go back to the question, I'm going to highlight where it says what it's going to be. Here we are. After the reaction has reached equilibrium, the hydrogen gas equilibrium concentration was determined to be 0.30 moles per liter. So now I have a bit more information. I'm going to take that information and put it down into the table. This is where I think you're going to get a little bit confused, but I think we can do this. Okay, how do I know? Well, I'm going to start with, which one's the easiest one to start with? Yeah, I guess probably here. Okay, this is my 1, 3, and 2. Can you see here how if my answer is 0.30 for my hydrogen gas, can you see how my change in concentration for my nitrogen gas is going to decrease by 1/3 of that? Because my nitrogen gas and my hydrogen gas are going to decrease by the same ratio, if you will. Is that the right way to say that? But my nitrogen is going to go down, my hydrogen is going to go down, and if my hydrogen goes down to be 0.30, what's 1/3 of that, right? 1/3 of that is going to be a change in concentration of negative 0.12. It's going to go down, and so I know what that concentration is going to be over here. Okay, does that make sense? This is the hardest one of all, I think. Let's look at my ammonia concentration on the other side, okay? It's going to go up, right? Why? Because it started with a 0 concentration. So clearly at equilibrium, that concentration is going up. It's increasing by a factor of 2/3. Where does that come from? Again, it comes from the fact that if this one goes down by whatever the value is that you can solve for that, okay? 2/3 of that is how it's going to change for your NH3. And so when you do that math, and again, this one is tricky, so see if it makes sense once you really look at all that math to figure out what that change is going to be. Basically, you were given the information of what the concentration of the hydrogen gas was at equilibrium, and then you had to work your way back to figure out what the change in those concentrations is going to be. Okay, so that's tricky. Once you've got that value, then you substitute it in, solve for K, and away you go. All right, so those are lots of calculation questions here. They'll all be in the solution set, and believe it or not, we're actually almost done our equilibrium unit number 4, right? And so we should be able to maybe do the little assignment that's on driving forces. That's a great little lesson, and it would be something that you could hand in to me. I'll let you correct it maybe. Do it, correct it, and then submit it, and we can do a quick little quiz at the end. So essentially, I'm thinking that we're ready next week. Next week will be the 3 modules, and then we're done unit number 4, and we'll start unit number 5. Okay, take care. Let me know how it goes.